Hey guys, so a lot of yesterday's review video topics you will see again today in today's Edcite assignment, but there are some topics that we haven't seen in a while that are also in today's assignment, so I wanted to give you guys another video of some review topics. So example number 1 just wants us to give the abbreviations for the 5 congruence theorems to prove triangles are congruent and what they stand for. So remember, this was back in chapter 5. So the different ways that we could prove triangles were congruent were side, 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 that's SSS. We also had side, angle, side, so SAS. Then we had angle, side, angle, ASA. Then we had angle, angle, side, AAS. And the last one, remember this was the special one that only works for right triangles, that is hypotenuse leg, HL. Okay, so you have lots of different ways to figure out if triangles are congruent. Remember, those do need to happen in the order they're stated in those abbreviations. So side, angle, side means the angle has to be between those two sides. So just be careful about that. Okay, so here's an example that goes with those. In the diagram, QS and RP pass through the center M of the circle. What can you conclude about triangle MRS and triangle MPQ? So just looking at the shapes, I know that these go through the center of the circle. Okay, remember, if it goes through the center, that means this is the diameter of the circle. So these are my radii. Remember, all radii are the same. So I know that M to S is the same distance as M to Q. M to R is the same distance as M to P. So I'm going to go ahead and mark all of those congruent, and then try and figure out anything else that I might know. So just looking at these shapes, I want to know, can I use any of these theorems? So right now I have sides, so maybe it's the side, side, side. Maybe it's side, angle, side. I have 2 pairs of sides, so I'm not going to use this one or this one, and I don't know that they're right triangles. So I'm looking at either SSS or SAS. Okay. So what I'm going to do is figure out, are there any angles that I can find? Because right now I don't know that I can prove those other sides are congruent. So other angles that I can find might be right here in the middle. And if you remember what those angles are called, yesterday's video, we talked about those. Those are your vertical angles. And so those look like angle SMR is congruent to angle QMP because they are vertical angles. So then I know that my triangles MRS and MPQ are congruent because of side, angle, side. Okay, so we can conclude those triangles are congruent because of side, angle, side. Okay, next thing we're going to talk about is from chapter 6. So this was chapter 6 before we went on Christmas break. It's all about the different lines that we can create within a triangle. Okay, so question number 3 says, what is the perpendicular bisector of the triangle? And I have this as a matching question over here, so we're looking for one of these as the answer. Remember, perpendicular, I'm looking for that right angle, so I only have a couple that have that right angle in there. And then I'm looking for bisector, so cuts in half. Okay, so I'm looking for a line to be cut in half. So for number 3, you should be looking at this line right here. I've got the perpendicular, and it is cutting AC in half. So that should be D as my answer. Okay, so we use D. Second one is the median. Now remember, the median connects the vertex to the opposite midpoint. So I'm going from vertex B to the opposite midpoint. Now we just said this was a bisector, so I know that's the middle. So I'm going to say this should be BF. So that should be answer C from the matching. Okay, then we have our angle bisector. So angle bisector, remember, cuts an angle in half. So I'm looking right here, and it looks like this one cuts my angle in half. It's kind of hard to see in this picture, okay, but that should be BE. as my angle bisector. So that's going to be A. Okay, maybe if I get them closer up here, you guys can see those are the same. Okay. And then the last one is my altitude. Remember, an altitude also has a perpendicular. So I'm looking for another right angle. It just goes straight down from that vertex to the opposite side. So this one should be BD. So that should be B as your answer. Okay. So this is straight from chapter 6. Okay. All right, and the last thing we're going to talk about today is transformations. Now, this is back in chapter 4 that we did all of these, if you guys are referencing your notes. So chapter 4 was a bunch of similarity transformations. We also did congruent transformations. Okay, so remember, we are looking for things like rotations, reflections, translations. And because it's a similarity transformation, we can also have a dilation here. Okay. So the first thing I'm going to look for is, did I rotate my shape? How do I get from the black pre-image to the dashed image? So it looks like I did not rotate my shape over. So I don't have a rotation. I didn't take it and just move it. So that's not a translation. So I'm looking at, is it a reflection? So if I took this and I reflected it over, I would end up with something that looks like this. Okay. Now to me that looks pretty close, just the size is a little bit wrong. So I'm going to go ahead and say this is a reflection over the y-axis. Now remember, when you write these, my original points are written first, and then you draw that arrow. Okay, so xy implies this is going to, and then our shortcut here is a negative xy. So we change that x value, we negate it, but the y value stays the same. Okay, then since the size is wrong, I know that I have a dilation. And my dilation comes from how big or small the shape got. So going from that green new shape to the dashed shape, I know that I'm getting bigger. So this is an enlargement. And I just have to figure out an enlargement by how much. So that's where the scale factor comes in. So this point right here, this graph counts by 2's. So this is actually at 1, 1, okay, or -1, +1. And I want it to go to point W prime up here. So I want it to go to -2, 2. So how do you get from -1, 1 to -2, 2? Right? You multiply by 2. So my scale factor is 2, which means it's twice as large. So remember, when you're writing that, it could look like this. xy implies 2x, 2y. So you're multiplying both pieces by 2. Okay. Remember, if you have any questions, to email or contact us through Teams, and all of your teachers will try and get back to you as soon as possible. Thanks, guys. Bye.